This is the principles of the innate and adaptive immunity, chapter 1.2 on lymphoid lineage. As these lectures proceed, please make sure to subscribe by clicking the subscribe button and following along, and to like the videos as you go. If there are any topics you'd like me to cover, please comment below. This is epitope Immunobiology session number 2. Now let's begin. So last time we covered all the cells in the myeloid lineage, which is shown here on the red and also on the right hand side. This lecture is primarily focused on the lymphoid lineage, shown here on the blue, in the blue on the left. Today we'll be going through common lymphoid progenitor into the B cells, T cells, and natural killer cells, and essentially the principles of how all this works. Well, the lymphoid lineage. Well, the common lymphoid lineages in the bone marrow, the common lymphoid progenitor in the bone marrow gives rise to the antigen-specific lymphocytes of the adaptive immune system. So a lot of the cells that you see here is actually a part of the adaptive immune system. Last time we talked about the myeloid lineage cells. They give rise to a lot of the innate immune cells. This one is the adaptive immune cells, with the one exception of the natural killer T cells. So that's signified here by NK cells. So you see here, they're on this side here, the NK cells. This is one exception that is not a part of the adaptive immune system, as these are not antigen specific. And that will make more sense to you as we go along. They are not antigen specific, which means that they are part of the innate immune response. Okay. So each lymphocyte matures bearing a unique variant of a prototype antigen receptor. Okay, so the population of lymphocytes expresses a huge repertoire of receptors that are highly diverse in the antigen binding sites. Essentially, what this means is that if you can collect all the different antigens that your lymphocytes can bind to, they can bind to nearly anything. And this is a key to their survival, since antigen binding is what allows clonal expansion, or what we say is clonal expansion. It really just means for the survival, proliferation, and differentiation of these cells. Okay, so as you see here, almost always will be a lymphocyte that can recognize any given foreign pathogen. So you see here, there's 4 different lymphocytes here, and they actually have these receptors that bind to different antigens. And you can see here, this one may bind to an antigen that is like a square. This one is like, say, the flat side of a rectangle. This one is binding to this Pac-Man-like structure, and this one is to this fat X structure. Okay, so essentially these ones, if they can successfully bind, then they can go on to proliferate and differentiate. So lymphocyte activation essentially goes like this. We got a lot of naive T lymphocytes here, and these naive T lymphocytes essentially they mean that they are naive. Okay, so let's say, for example, that there's a naive T lymphocyte circling the blood. Okay, and it hasn't bound to any antigen yet, and that's what it means by naive. It has a T cell receptor, or it could be a T cell receptor or B cell receptor that hasn't been essentially accepted by the immune system as a way that protects the human body. So let's see here, this one binds to, let's say this is the virus particle, and if it doesn't bind, say it just bounces off. And it would do that maybe a few thousand times throughout its entire lifetime, about 3 or 4 days. It would basically bind on and off with a bunch of different antigens. It turns out that if it doesn't successfully bind, okay, this one doesn't successfully bind to anything, it'll eventually just die. Okay, in 3 to 4 days. My apologies. That'll eventually just die. So bounces off and it dies. In this case, let's say, for example, this one here has an epitope, sorry, not an epitope, a receptor that can actually bind to this virus. You can see here it fits right into this V shape here. Let's say it binds, and it binds perfectly. What happens is that this T cell is then signals intracellularly to tell this cell to survive. This one dies, this one survives. And this one will then differentiate into an effector T lymphocyte. Okay, actually, I mean, I use T lymphocytes here as an example, but these could be B cells as well. So what this leads us into is that if it's T cells, it would be for naive T cell to an effector T lymphocyte. If it's a B cell, it would be a different thing. But essentially, upon antigen binding, okay, these naive T lymphocytes become effector T lymphocytes. If they don't they die. So what happens here is that, for example, with B cells, um, B lymphocytes, so they're naive. Upon antigen binding, they actually turn into these plasma cells. And as you may have already learned somewhere else before, the B cell receptors are essentially antibodies, okay, that are just essentially mounted to the cellular membranes. And let's say this binds properly to an antigen, then this can then differentiate into a plasma cell. And a plasma cell then secretes a lot of these antibodies that recognize a certain foreign antigen. And as you can see, then they release all these antibodies. Okay, so if it's going to make antibodies, which are proteins, it must make a lot of proteins, and so therefore that's why you can see here that plasma cells often have very, very extensive networks of their endoplasmic reticulum where a lot of proteins are made. So again, naive cells and naive B cells will then mature through antigen binding to plasma cells, and a plasma cell that's an effector cell will then actually produce a lot of immunoglobulins or antibodies to essentially bind and neutralize these foreign antigens. And for example, with T lymphocytes, let's say this T cell receptor gets properly activated by whatever the pathogen may be, they can actually go to an effector T cell, and in this case, the effector T cell could be three different types of cell, well, large umbrella types of cells. The first one is a cytotoxic T cell. Their function is to kill cells infected by intracellular pathogens. Okay. The second one is an helper T cell. Okay, they signal B cells to produce more antibodies. Also, they signal. This is one point. This is another point. They signal macrophages to kill more efficiently. And the third type is a regulatory T cell, and they suppress the activity of other lymphocytes to balance the immune response. So essentially, these regulatory T cells just essentially send out signals, cytokines, and so on, just to tell the body, tell the immune system in this area how much of an immune response needs to be mounted and whenever it needs to turn off. So essentially, it's a nice balance. One thing to just not mention here is that these helper T cells, I said, they signal B cells to produce more antibodies. Okay, it's not just simply antigen binding here. You actually happen to need helper T cells to actually help activate these plasma cells, and that's a process that we'll get into much detail later on in the series. But essentially, these plasma cells also need antigen binding and a helper T cell to then start to make immunoglobulins or antibodies. Okay, one note here is that some of the B cells and T cells differentiate into memory cells. Okay, so they actually stick around and they stay as what we call memory cells. The lymphocytes that are essentially responsible for the long-lasting immunity that can follow exposure to disease or vaccination. Memory cells would readily differentiate into effector cells upon second exposure to the specific antigen. So let's say you have a memory cell, a memory T cell, a memory B cell to just a common cold. Okay, the point is that if you get that same infection from the common cold virus, you would be able to mount an immune response to get against it really quickly, so that you don't fall sick. But the reason why we fall sick again is because these common cold viruses often they mutate and they change a little bit, and then therefore we need to make another type of immune response to it again. But that's essentially the basis of how vaccines work. You actually want to generate certain portions of the protein or the pathogen or virus that is consistent throughout all the different strains of that virus, so that even if they mutate, that portion of the protein or that portion of whatever the antigen or pathogen may be does not change, and you can always attack this type of virus or bacterium. Okay, so let's talk about lymphocyte maturation. Lymphocytes circulate in the blood and the lymph, and are also found in large numbers in lymphoid tissues or lymphoid organs. Okay, these are organized aggregates of lymphocytes in a framework of non-lymphoid cells. All right, so you see here, there's lymphoid organs you can separate into two different categories. One is the central or the primary organs. This is where there's a generation of lymphocytes. This would essentially be the examples of this would be the bone marrow and the thymus. And the other ones would be the peripheral organs. So these are the secondary. Some people say primary and secondary, or some people say central and peripheral. It really depends on what curriculums you're following, what kind of, or who's essentially teaching the curriculum. And essentially, peripheral is where all the naive lymphocytes are maintained and adaptive immune responses are initiated. So let's say, for example, let's begin first here. The peripheral organs will, for example, be the lymph nodes, the spleen, mucosal lymphoid tissues. So this is in the gut, nasal, and respiratory tract, and the urogenital tract. What connects these two is what we call the lymphatic system, similar to the blood system, but essentially mostly for the lymphocytes to be traveling between. And essentially what happens is that when these lymphocytes generate and mature in the bone marrow or thymus, they go through into the peripherals, which is outside of these areas, where they exist as naive lymphocytes. And eventually when they bind to an antigen or whatever the activation signal may be, then they can then mature into the full form in many of these peripheral organs. And this essentially would be like lymph nodes and spleen, very, very crucial for example, T cell and B cell maturation. But one note we have to talk about here is that both B and T cells are generated in the bone marrow, but only the B cells mature here, okay? The B cells mature here. The precursor T cells migrate to the thymus. Prior to maturation, naive B cells and T cells, my apologies, is enter the bloodstream to circulate the bloodstream and through peripheral lymphatic system tissues. Okay, so again, they mature here where B cells mature also in bone marrow. T lymphocytes would go to the thymus as well, and eventually, when the antigen presenting cells, sorry, my apologies, the antigen presenting cells such as dendritic cells or monocytes or macrophages are presenting the antigen to the adaptive immune response system, then they would possibly be showing it in the thymus or lymph nodes, where then they can tell these naive T lymphocytes to then mature into effector T lymphocytes or effector B cells and so on. In summary, lymphoid progenitor in the bone marrow gives rise to the antigen-specific lymphocytes of the adaptive immune system, with the exception of natural killer T cells. Remember, the natural killer T cells is, although part of the lymphoid lineage, it is a part of the innate, okay, innate immune responses, okay. B cell receptors and T cell receptors are highly variable in their binding targets and therefore represent the repertoire of your immune system. So as they're generated, these B cell receptors and T cell receptors, they are highly variable. They basically can bind to almost any antigen possible. That's what one of the next few lectures will be covering, essentially how that happens. And this will essentially make your immune repertoire prior to, well, the naive immune repertoire. And efficient binding of a target pathogen by B cell receptor or a T cell receptor signals the corresponding B cell or T cell to no longer be naive, but an effector lymphocytes. So again, for it to become from a naive to an effector lymphocyte, it must bind properly to an antigen, a foreign antigen. B cells become plasma cells that release antibodies, okay, specific for the pathogen. These, for example, the logo of the epitope Immunobiology, this is an antibody. T cells become cytotoxic T cells, helper T cells, or regulatory T cells. Both B cells and T cells become memory T cells. Again, this was the basis of vaccines, okay, and also why you wouldn't get sick from the same virus again unless it mutated. And lymphocyte maturation starts in the bone marrow. Okay, B cells mature there while T cells migrate out and mature in the thymus. And this is through antigen presenting cell. Okay, so I just want to get more into detail. This will be following the next lecture. You see here, it'll be chapter 1.3 on chemokines, cytokines, and clonal expansion. Essentially, clonal expansion is what happens when the cells are successfully bind to an antigen and then can therefore proliferate and differentiate. So you can click here to get to that video. So again, make sure to subscribe and like this video for future series on immunobiology topics and also biochemical topics. And this is epitope immunobiology. and we'll see you next time.